10:30 से स्टार्ट है?
10:30 पे करेंगे सर स्टार्ट।
10:30 से स्टार्ट करेंगे, ओके।
बस
तो
सर मैं आपको
अच्छा
को
लगा
होस्ट
सर।
बना रहा हूँ, 1 मिनट को होस्ट बना देता हूँ आपको ना।
अच्छा, होस्ट बनाएंगे तो फिर क्या करना होगा मुझे?
आप शेयर स्क्रीन कर पाएंगे ना सर?
अच्छा, ये तो शेयर, अच्छा अभी नहीं हो रहा क्या शेयर स्क्रीन?
अभी
दिख तो
देखिए
रहा
सर।
है सर, मैं कर पा रहा हूँ, देखना एक मिनट जरा शेयर करके एक बार, मैं चाहता हूँ कि चेक कर लें सर। एक बार देखिए, मेरा ये दिख रहा है?
हाँ अब दिख रहा है सर।
हाँ सर आ रहा है।
आ रहा है ना? क्योंकि और आ जाए उससे पहले हम ये एडमिट तो आप लोग करते रहेंगे ना सर, ये मुझे करना होगा?
क्या?
जो एडमिट करना है, 3 पीपल
एडमिट तो
एंटर।
सर हम करते रहेंगे, बैकएंड पे आपने सिर्फ लेक्चर देना है।
अच्छा, ये जैसे यहाँ से स्टार्ट हो गया, कहाँ ये तो स्क्रीन ही नहीं चेंज हो रही मेरी। हाँ, हो गई चेंज।
हाँ जी सर,
सर
एक बार
दिख रहा
आप
है
ना,
यहाँ से?
आप इसको
मल्टी
प्रेजेंटेशन मोड में ले जाओ सर एक बार ना।
हाँ सर, वो तो प्रेजेंटेशन मोड में तुरंत चला जाएगा, फिर सारे हाँ दिख रहे हैं अभी तो मुझे, है ना? ठीक है सर। तो ये नजर आ रहा है ना?
हाँ जी हाँ जी, मल्टीपोर्ट कन्वर्टर्स।
मल्टीपोर्ट कन्वर्टर, यही टॉपिक था हमारा, है ना?
यस सर।
और ये पूरे स्क्रीन में दिख भी रहा है। ठीक है सर, फिर जब आप
बस
बोलेंगे तब स्टार्ट कर देंगे, तो मैं क्या अभी एग्जिट करके फिर आऊँ?
नहीं नहीं सर, आप बैठिए ना, आप बेशक आपका जिसमें पार्टिसिपेंट्स को आपका इंट्रोड्यूस करवा दूं, देन
हम्म।
यू कैन स्टार्ट।
हाँ, क्योंकि आपका काफी और आप लोगों के सर और बाकी लेक्चर्स बाकी आप यूट्यूब में डालेंगे या कैसे मिलेंगे?
ये यूट्यूब पे करेंगे सर अपलोड।
यूट्यूब पे अपलोड कर देंगे, ठीक है।
हाँ जी।
तो
आज
ये
12 बजे, आज बात पिल्लई सर का अभी बात हुई थी उनसे आपसे जस्ट पहले।
अच्छा, उनका 12 बजे से हो गया है मेरे
12 बजे से सर उनका।
अच्छा, समझ गया मैं, ठीक है। तो मैं जल्दी खत्म कर दूंगा फिर।
11:45 तक सर।
हाँ, 11:45 तक है, ठीक है। मैंने तो छोटा मोटा ही सर, क्योंकि वो एक्चुअली एप्लीकेशन आप लोगों के थोड़ा वो पावर सिस्टम में हो सकती है, लेकिन एरिया पावर इलेक्ट्रॉनिक्स है ना, कोर। और अभी वो आशुतोष जो कर रहा था ना पीएचडी, उसका कंप्लीट हो गया सर 10 अक्टूबर को।
ओके ओके।
वो उसके एग्जामिनर जो थे वो आईआईटी मद्रास से थे।
शांति स्वरूप सर।
नहीं नहीं, वो एक प्रोफेसर लक्ष्मी मैडम है, जो एनपीटीईएल के कोर्स भी करवाती हैं।
ओके
वो डीएसपी बेस्ड कन्वर्टर्स पे।
ओके।
हम्म। तो काफी अच्छा रहा। मेरे साउंड और उसका कहाँ से आएगा? साउंड को अगर मुझे ऑफ करना है तो?
साउंड का सर आपके पास ही होगा ना, ऑडियो एक लेफ्ट कॉर्नर में आपको
हाँ
ना डाउन।
आने ऊपर ऊपर आ गया सर, वो ऊपर आया।
अच्छा।
साउंड का ये रहा, ये माइक है।
हाँ जी, ऑडियो लिखा होगा ना वहाँ पे, सो
हाँ सर,
दैट
ऑडियो आ रहा
फ्रॉम
है,
वेयर
वो ऊपर
वेयर
चला
इट।
गया है, हाँ। हाँ,
अच्छा।
तो ये यहाँ से आवाज हो गई, और यहाँ से वीडियो को कैंसिल कर सकते हैं, तो वीडियो
We have
कैंसिल हो गई।
we are using Zoom because it is one of the best platform, I think. Voice quality and picture quality in this is very good as
वेरी
compared to other platforms.
बट इसका कुछ ये लिमिटेशन भी है ना सर, ये इतने टाइम तक चलता है, ऐसा कुछ है क्या, या
नहीं,
इतने यूजर्स?
हमारे पास प्रोफेशनल वर्जन है सर, वी कैन इन ऑलमोस्ट 1000 पार्टिसिपेंट्स विदाउट एनी प्रॉब्लम।
अच्छा, और कोई टाइम फिर आपने अगर परचेज कर रखा है तो टाइम का भी नहीं होगा ना, ये किसी
टाइम
पर्टिकुलर टाइम?
टाइम वी कैन सेट अकॉर्डिंगली सर, अदरवाइज वी हैव सेट द कॉन्फ्रेंस टाइम अप फॉर ईच कॉन्फ्रेंस 1 hour 30 minutes।
1 hour 30 minutes?
या
अच्छा, फिर तो
वो हमने
ठीक है।
सेट कर रखा है सर, बट दैट कैन बी एक्सपेंडेड।
अच्छा, फिर तो बहुत अच्छी बात है अगर ऐसा है ना। बाकी मैं आपका लिंक्डइन और उसमें देख रहा हूँ, आप लोग डाल रहे हो ना उसका, ये मैं एक्चुअली वो अपडेट भी डालते रहना, ठीक है ना?
हाँ जी हाँ जी सर।
हम्म, ठीक है सर, अब 1 मिनट रह गया तो
हाँ जी
टेन
हाँ जी।
थर्टी
हाँ सर, बस जस्ट अ
पार्टिसिपेंट
मिनट।
तो
लेट मी इंट्रोड्यूस योरसेल्फ एंड देन वी कैन स्टार्ट।
जी सर, ठीक है।
Okay. Let's let's start, sir. And I welcome all the participants and our guest experts of the today's lecture, Dr. Dheeraj Joshi. So let me introduce himself. And Dr. Dheeraj Joshi is a professor in the Department of Electrical Engineering at Delhi Technological University. It was formerly known as Delhi College of Engineering. And with over 2 decades of teaching and research experience, he holds BE, ME, and PhD degrees in electrical engineering. ME he has completed from IIT Roorkee and PhD from NIT Kushetra. His areas of expertise include power electronics converters, renewable energy systems, optimization techniques, and electrical drives. Dr. Joshi has guided several PhD scholars and has published numerous research papers in reputed journals and conferences, including IEEE transactions. He has also authored books such as Power Electronics, Drives and Advanced Applications from CRC Press and Optimization Techniques in Engineering, Advances and Applications by Wiley. His academic contributions reflect his commitment to making advancements in research and education in modern power and energy systems. So I welcome Dr. Joshi for this particular lecture. So I request him to start his presentation.
So thank you very much, Professor Agrawal. And I think I'm audible. Let I start.
Yes, sir.
And sir, my presentation is also in slide show form. So is it visible, sir?
Yes, sir, it's visible.
Okay. So first thing, good morning to all of us and my colleagues. I think all are from different institutes and expert in their areas. So let me start from this topic, which is very hot topic nowadays and utilized in power system as well as in power electronics area. Because and nowadays I'm working on conventionally on power electronics converters. So my thinking is to utilize it in electric vehicles, but that um, will be utilized for the grid for smart grids also, microgrids like smart microgrids and in power system area also. So let I start from the topic and we'll show you the screen. So you can see the earlier the distribution system with multiple CISO converters were shown like this, that we have the different energy sources like wind generation, solar generation, hydro generation, and from coming from battery also for backup. And we utilize it for the different loads like irrigation pump, milling machine, lightning, paddy, thresher. So this is about for agricultural applications. So we can think about the different type of loads also in the output side of the bus and think that this is a complete distribution system. You can convert this diagram for your power system, and instead of single converters, you can see for each source one converter is connected. Instead of utilizing the different converters, if we utilize one converter which integrates the different energy sources to different loads. So it is conventionally called multiple input and multiple output converter. So you can see in the input side, different type of sources are there, different voltage and current levels are there. Similarly, in the output side, different requirements are there. So we have the DC loads or AC loads or different type of systems in the output side also, and different voltage and current rating. So accordingly, that MIMO converter will be utilized. Now, because I am working in power electronics area, so I assume it like this, which you think like that. I can assume like this in electric vehicle also. We have the battery, the input. We may have the renewable energy sources like in the RES. We can take it as a PV, solar PV. RES2 you can take it as a fuel cell. So in that manner we can think, and after that for electrical motor we can utilize another converter and the controller. uh, because my topic is multi-port converter, I forgot to write multi-port DC to DC converter. Instead of multi-port converter, we can write it as multi-port DC to DC converter. But for the generalization, we can also write it as by the integration of the inverters, means DC to AC converter in the output side. We can say it is a multi-input, multi-output converter. So converter is a general term utilized for DC to DC or DC to AC or AC to DC, like that. And we can, when we say the power factor correction converters, we can also think like that when chargers are there. So that multi-input converter may be connected to AC supply, and then one AC to DC converter will be there that is connected to this multi-input DC to DC converter. So various things may be possible. So it is the one way which I want to explain it. It's like an ocean. Now, let me go for the basic review very fast. We have the different DC to DC converter topology as per my this particular lecture. So different DC to DC converter topologies are possible, that isolated and non-isolated converters are there. Where in the non-isolated, we have the conventional DC to DC like boost, buck boost, Kirk, Sepik. Again, it was written only up to Sepik. So we have again say there are several type of non-isolated converters, 1,000 type of topologies are there. So I'm just writing only for the knowledge point of view. Okay, we can convert it as a non-isolated, isolated. We can also think as a common ground, non-common ground, like that. So we have these are say generally single input, single output converter, as available in the literature or in the books, in the earlier books. So for isolated one, we have the bridge type of converter, full bridge and half bridge. And again, nowadays work is going on how to reduce the size of the converter and increasing the efficiency of the converter. So we utilize again resonant converter. So means various topologies and various type of converters may be possible. So I'm just writing this one. So we have push pull forward flyback. So last one is multi-port, that I started from that the lecture, that is a multi-port converter. So the combination of these two non-isolated isolator may be multi-port, or the different isolated and isolated configuration may create the multi-port converter, like that. So that different topologies are possible, but we have to think about these applications, like the for electric vehicle, which is a hot topic nowadays. And you can think in a power system also in that manner for AC load, DC load. Now you can see the general advantage and disadvantage. This is only for the revision purpose. So we can say for a boost converter, the voltage gain will be less than 1 and the ripples are high. So improvement in the boost converter is basically interleaved boost converter, where number of inductors are more than one and the switches are maybe more than one. So it will reduce the voltage ripple. It will cause the high switching loss, and the number of components are more. If somebody is working on reliability area, he can think about that apart from the power electronics area, that what is the reliability of the boost converter, single boost converter or interleaved converter, or in this type of this one. So whenever lectures are there, we have to think about the different areas we can work on. So I just compare it and I will do I did some work and I will show it to you in that manner. So you can see again a boost converter with resonant circuit is there. So you can see in that case soft switching techniques are used, and this one additional branch is connected here, and we can utilize this converter for high switching frequencies. Now this is a full bridge boost converter. Here in the input side a inductor is connected, that's why it is called boost converter. If it is removed from this circuit, we can say it's simple full bridge converter, and generally it is used for step down purpose. So in that case, again, you can see a transformer is connected here, and we have to properly design that particular transformer. And it is used in battery charging applications where we want the isolation between the input and output. Uh, in power factor correction circuits. So again, you can see in that diagram where the output side diodes are there, we can connect the switches, and then we can transfer the power from input to output and output to input. So nowadays, uh, du dual active bridge converters are used. Work is going on that also, that side. Then we have isolated ZVS converters, and again, high current rating is required here, and we can see the switching technique is different. Instead of hard switching, we are using the soft switching. This is the combination of the full bridge and half bridge converter, and it is used up to certain power rating. For high power rating, it is not used. So similarly, in this case, as per our lecture, the multi-port converter came into picture, where the two input sources, the battery and the capacitor, or maybe fuel cell or maybe solar panel, like that, can be converted, or the transformer primary winding, and in the output side only one load is connected. So again, various configurations are possible. Instead of that switches, we can use the diodes in the output side, and then say the output is there by connecting on the black box, that is the not black box, blue box. We can connect the inverter and then give it to the our motor, which I earlier showed you, that the electric vehicle we can utilize it. So these converters are utilized for different applications. Here the two inputs are there and one output is there. So let me start from this one. This is called multi-port converter, where the two inputs and one outputs are there. So similarly, this is the another type of multi-port converter. The number of switches are more here, and it is little bit complicated than the previous one. So the efficiency is high in this case. Uh, Based on this, some converters, we can compare it in terms of the polarity of the output voltage, the complexity, the high power conversion, the ripples, the current and voltage ripple both, EMI suppression, which is also very important, switching frequency, then multiple input out ports. Here it is was written multiple input port only. So you can see here multiple input ports are there in each configuration. This is only one port, but here no, more than one. Here we can say multiple inputs are there. So when we say multi-port converter, it may have multiple inputs and single output, or single output, multiple outputs, single input, multiple outputs, or multiple input, multiple outputs, MIMO. So CDO, CISO, CISO is single input, single output. So CDO, DSO, MIMO are basically the multi-port converter. So this is another configuration. So this is the comparison. Now, different MIMO configuration, which I showed to you like this, that different inputs are connected to one load. So why not, instead of different converters, we can make one multi-port converter, where the three different or more than three inputs are connected to the one load. Okay. So this is the one configuration. Now we may have this configuration where multiple single input, single output converters are there, where we can make a one DC bus, and on a proper closed loop control, we can tightly regulated, we can develop tightly regulated DC to DC converters for a particular output voltage, and will be connected to a DC bus. So the people who are working in power system can think like this as one DC bus is there. First DC to DC converter may be boost converter, where the input supply is from solar PV. So different MPPT schemes can be connected, and then accordingly we can generate a DC bus. And the second converter, maybe here two, more than two can be possible. Second will be connected to the battery. So if the solar is not available, by the battery we can provide the DC bus. Now, by that DC bus, we can connect, maybe it is not shown here, we can connect the inverter also, and we can run a motor, AC motor, or we can provide it for the lightning purpose or different type of DC loads by the DC to DC converter. And we can also connect the isolated converter here, if we want to use for the battery charging application generally. So in that manner, by this diagram, we can say different CISOs are connected, but one DC bus is there, and then we can do the work like that. Now, second way is we have a MIMO converter, multiple input, multiple output converter. We can think about it one configuration, different configuration here, and then it has multiple input and multiple outputs. So that can be possible by this also. Uh, this is another configuration where we can say the different converters can be connected in parallel in the input as well as in the output side. So you can easily see that in the input side, different converters input cells are there. In the output side, different output cells are there, and different outputs are there. Different type of output may be possible. So this is another configuration where we can connect the different converters in series in the input side as well as in the output side. So now by this two configuration, we can also think series parallel configuration. So somebody who is working in solar panel area, in solar energy area, uh, who is working on the series and parallel combination of solar cells. So by making some solar panel or doing research work, he can also think that the converter also can be connected like series and parallel to provide the different voltage and current levels. So these are called the MIMO converters. So now I'm just writing here for EV application. We can say multiple energy sources are used. So that's why it is for EV. I wrote it. We can use multiple sources as photovoltaic, and we can have even output has become multiple, and you can say for use for cabin lighting and ventilation, the other for electric motors like that. Uh, so it is possible that we can use a CISO and we can use MIMO both. And why MIMO? Because the size will be less. It will be, we cannot say it is cheap, because it depends on configuration also, but definitely when CISOs are there, it is bulky and costly. So when one converter is there, there are chances that if that converter is not working, the system will be gone. So if we use the CISO converter, multiple CISO converter, it may be possible if one converter is not working, the others are working. So there is again optimization between the various topologies, and work is going on that direction. So this is I told you that we can work on fault tolerant multi-port converters also. We can find the thermal management of the multi-port converter. So various areas are possible. In this lecture, only my aim is to just tell you that, okay, in that manner, we can work on different converters. So again, in the literature, it was written, which I already discussed earlier, that we have the uh, isolated converter or non-isolated converter. And again, when non-isolated converters are there, the problem is that if some in interference is there in the input side, it is transferred to the output side. So we have to work on EMIs. So we have to work on differential noise and the other type of noises for that. So again, when we think about the converters for application, accordingly, we have to think the various issues related to it. Then we have the different type of multi-port converter. Again, the same thing. We have the capacitor based, where for high gain capacitors are there. We have switch capacitor converter. We have coupled inductor converter, interleaved converter, like that. So the area is very vast, and the people can work according to the application. So again, there is another uh, classification. So it is called different topology. So we can say we can use this MIC is basically multi-input converter. So we have the isolated type of multi-input converter which we can use flyback or forward converter which has two, three inputs and one single output. And the control will be done using different control strategies. So again, another area is open to all of us. The different control strategies are used. Like the person working on the uh, PV, they are using different type of MPPT techniques. So here we have different type of control strategy to control this converter. Um, because whenever we have to discuss the converter, one is its topology or structure, the other is its design, the third is its control, and then the performance analysis. So you can easily see that the limitations of the first converter or topology is high component count and right hand one pole is there, or zero is there. So you can say that in the right hand side, when we find the transfer function, uh, 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 right side, if some pole or zero is there, so uh, right half side, it will create the instability of the system. So again, this is again another research area ki we have to study the non-minimum phase systems or minimum. Why not we are using the minimum phase system like that? Then there is, you can see non-isolated boost derived converter where two inputs and dual outputs may be possible. So just by using the diode and the capacitor configuration, we can make the different outputs also by using the inductor, and by reducing the current ripple, we can use the different outputs also. So again, topology, whenever we write topology, we can develop the new type of converters by the basic converter. So generally, when we did work, we can start from simple boost converter and then we derive the different type of converters. So again, ESR modeling may be possible, and different nonlinear controller can be applied for such type of topologies. So work is vast. uh, by this you can just see that that is possible. And the other part, that is the limitation, you can take it as the research gap and you can work on it, like this sliding mode control approach. Different type of sliding mode control approach can be used. Different type of nonlinear control, like it was not written here, model predictive control is used nowadays in your multi-port converters or everywhere, uh, due to the robustness of this technique. So you can see that again, different another topologies which are possible can be written like this. Then, because we did some work in our lab, so um, you can see here, um, three input sources are there. So these three input sources are connected in such a manner that the input side energy battery is there, and then this V1 and V2 may be the renewable energy sources. So we can think that three sources are connected in such a manner that we will get two outputs. So two outputs are basically VO1 and VO2. So this is one topology. We can, but the number of switches are 1, 2, 3, 4, 5, and we can uh, apply proper control strategies so that we will get very high gain, very high efficiency, proper line regulation or load regulation by this converter. Then there is another topology. Here we can see again the number of switches 1, 2, 3, 4, 5 here. So here again 1, 2, 3, 4, 5 switches are there. So if we compare any multi-port converter with the other converter, we have to see that the number of components or the component count, as well as we have to see how many sources are there in the input side and how many outputs are there. So you can see in the first configuration, the number of switches are 5, here also 5. So number of inductors are 1, 2, 3. Three inductors are there. Here, one inductor is there. You can see. And here the capacitors are, obviously the load is same. We are assuming that the high value of capacitor is connected so that the voltage ripple will be very less. So the difference between the two topologies, maybe here the number of inductors are more than that. Sorry, not more than that, are three, and here the number of inductor is one. So it is single inductor multi-port converter. We can name that particular converter like this. So when we have the topic multi-port converter, we have to think like this: the configuration, then that configuration comparable with the other configuration with the same number of component count, and will provide the more voltage gain, m- high efficiency, less EMI, like that. So in that manner we can work on our multi-port converters. And in the starting I told you that you can think in a power system, you can think, you can integrate the mm, renewable energy sources and by this single converter, and then in the output side different type of load may be possible. You can think where VO1 and VO2 is there, so one VO1 is connected to inverter, because we are getting a this output voltage by the appropriate control strategy, we will get a constant voltage, and then we can run a motor by this one output. The other will provide some DC load. Or we can also think like that multi-level converter is used, and the two voltage levels are this VO1 and VO2, and if the two are equal, we can make a single phase inverter also, or a three phase inverter by that. So different applications are also possible, like power system persons who are working earlier on connecting solar PV to the grid. They are working on that in that area. Nowadays they are saying that this single phase grid is charging a charger. So the same work is there, but the naming is different. So they are saying that they are charging the battery now. Earlier they are saying that it is integrated to the grid. So power electronics persons or the researchers who are present in this lecture can also think that the goal is only to design a proper converter which cater the need of the input power and the load demand. You can think like that, and accordingly they can design a suitable control strategy for these switches so that the converter will be reliable and will give the high efficiency. So this is about the one configuration. So this is the another configuration. You can also see that here the number of switches are five, the number of inductor is one, and the number of energy sources are two, and the output is again two. So just by seeing that, we can say we are discussing this converter previously also. So you can see the difference between the two. This is again one inductor. This is here also has one inductor, but the the positioning of these switches S3 and S4, you can easily see, is different as compared to the this converter, multi-port converter. The rest remains same. You can, I'm just showing you again. You first see this one. Think about the output. Output is same as the um, next one, but the input, how the input are connected, having the single inductor, you can see just this one and the next one. In that manner, we can say just by connecting the switches, or you can say positioning of the switches, we can make the different topologies, and we can get the different outputs accordingly. Now we develop, not we, my PhD student developed hardware in the lab, just completed his PhD on this configuration. So we have different configuration possible, like you, this one. Okay. So and here we can also use the, instead of inductor we can use the switch inductor. For the capacitor we can use the switch capacitor. So again different topologies can be possible with this one, this configuration. Similarly for this one, similarly for this one. So for the this converter, we developed the hardware in the lab and saw that it will the ideal ideally efficiency is high, but practically when we perform the experiment, the efficiency will be low due to our mistakes that we are not providing the proper isolation with the other outside world, or we are using not the ideal components like we did in the simulations, or there are so many issues. So even then this topology will provide the very good efficiency around 90%. So we develop the hardware for this one and integrate the different energy sources with the output. So generally we can represent it like this also. When multiple input and multiple outputs are there, we can extend the input sources also. So it is very difficult, though practically, but in the simulation it is very easy. So just we have to increase. You can see in the output side, see this configuration. In the output side, see S5 switch and the upper diode. So if we extend it, see the next configuration switches. S after S5 we can make S6, S7, S8, S9, S10 like that, and the end we can provide a diode, and then we will have the different outputs. So a multi-level inverters after that for this different input voltage level can be formed, or different outputs can be taken from this particular converter. So this is about this one. And we also did work on this converter where two inputs and one output is sorry, two outputs are there, two input and two outputs. So you can see it is same, a little bit changes there, like this. What is the difference here? This one, here we assume the ideal sources, here we assume the uh, uh, some ESR of the particular inductor. So, and the capacitor also. So this is about the some work. And then next thing is, whenever we studied the any converter, we have to see different modes of this converter. Like we discuss the various topologies here. This one, this one, this one, or any topologies. We have to analyze it by providing the different stages of the analysis, by providing the different switchings, which you can see in the right hand side by gating signals G1, G2, G3, G4. Although five switches are there, um, five or one, two, three, four switches are there, but three switches are working at a time for a discharging mode operation of this converter, because it's a bidirectional. So if it is bidirectional, we can use the four switches um, according to the charging or discharging mode. So you can see here at a time three switches are working. When G1 is working, G2 is not working, G3 and G4 are working. So accordingly, the inductor current waveform is coming like that. In steps, the voltage is coming and the inductor current is increasing in that manner. So we will get the output accordingly. Uh, there are chances the direction of the switches is wrong in this one. The S4 is correct, but maybe this one. So anyway, so we can easily see that the different modes are also possible when the switches are conducting. Um, Here by this diagram, we can see G1, G3 and G4 are conducting. So accordingly, that is the first switching state. In the second state, G1 is conducting and G4 is conducting. In the next one, uh, G4 is conducting. So in that manner, we will analyze this particular converter circuit and get the output accordingly. After writing the switching modes, we can write the equations like this one in the form of here it is shown in terms of matrices, but we simply by applying the KCL and KVL for each mode, we can write the state space equations. So that one written here, mm, which we can see if somebody, because whenever these type of such programs are there. Generally, faculty members are there who are already working on it and doing some advanced work also. But if some students are there, these lectures are also must be useful for them also ki how we do it. So that's why I wrote these lines here for those students, MTech students. If some MTech students are also attending such courses, or if some BTech students are attending, ki for controller design, we have to go for dynamic modeling, means small signal modeling must be done. So which starts from first writing the KCL and KVL for each mode. After that, averaging has been done. After that, perturbation is there, and then a small signal and large signal or a DC model was developed. Based on that small signal, transfer functions are formed. By this transfer function, we can develop the Bode plots uh, or any technique, and we find the its performance indices like crossover frequency and the phase margin. And according to our situation, we apply the different controllers. I am talking about linear PI controller or PID controller. And then we apply the uh, controller, and then we find how much phase margin is there. And accordingly, because it is related to our stability, so we design the proper controller by that. This is the one way. Second way is that we can use the average model and directly apply the Lyapunov technique, develop the Lyapunov controller and do it. The third technique is, there are several techniques. We use the sliding mode controller where we develop the different surfaces, and then by simple equivalent current law, we can check whether the system is properly working or not. And there is another way we convert this system into discrete form, and by predicting the future states, but providing the control signal at kth state, we can apply the model predictive control for such converter. So we must have the knowledge of these terms are used for the students who are working on it, because the other who are working on already working on it and doing some great work, they already know it. But it, whatever these lines are there, these are for those who just started the work on the multi-port converter or designing the converters and developing the controller for it. So by that we can develop the controller, then we check the performance of it, whether it will provide the proper line regulation by changing the input voltages, whether we are getting the proper constant voltage at the output, or by changing the load we are getting the same voltage, like that. So now it is again another area to design the converters and the controllers. But because our course is related to more related to a power system, so we have to say that we are designing the converters such that we are getting a constant bus voltage. For example, those who are working integrating the solar panel, solar PV to the a certain microgrid or some their system or a constant bus, they can say that uh, from the input side, solar PV, by we connect one converter which can which will provide you the maximum power to the load. And then we can uh, connect some other converter which take the power from the grid, and then provide the less harmonics in the input side. So they can say the input has the unity power factor, so they can work on like that also, unity power factor converter. So then after that they can say that out at the output side, the bus, because the DC bus is same, so the output of the solar fed converter will be given to the bus provided by the AC fed or single phase or three phase fed converter, and providing the DC bus. So again, it's a multi-port converter, but the sources are also different. Here we have AC and DC. So when I say multi-port converter, here actually I forgot that it must be multi-port DC to DC converter. They can work on the other type of converter which may have the multiple type of sources. Here I am, the input sources are all DC. Whatever I showed to the to our means our participants or my colleagues, not participant, all are my colleagues. So you can see here the input are all DC and output is also we are getting DC supply. So we can easily say they can also think that the input may be AC, the output may be AC. Why not we think like that? The input and output sources are also different types, so they can work on that one. I also got idea like that. So you can see that by that state space equation, we are doing the small signal modeling, and then we develop the transfer functions. And by this transfer function, we can easily control our this one, the switches. Not directly. By the transfer function, we can develop using that one. You all know, I think, we find the loop gain, and then by putting that loop gain equal to 1 and phase margin, by assuming certain phase margin, we develop certain value of the controller parameters, and then we design a controller also. So this is the part of the multi-port converter. When I say only multi-port converter, it has the topology of the multi-port converter, design of multi-port converter, which is not there in our this presentation. So I got idea. Then I can say that different control technique of multi-port converter instead of just showing you the diagrams. So we can, if somebody is giving lecture on the multi-port converter, can think also different type of sources may be possible. So this is only the idea. This is our interaction, that we can develop the uh, converter which has different type of sources, different control strategies like that. So we develop in the lab, not we, my PhD student developed the converter in the lab having three inputs. I told you earlier also, three inputs and two outputs are there. And it is basically non-isolated converter. So you can easily see that it has how many switching states? One, two, three.
मेरी ये वीडियो ऑन करते हैं
Hello.
There is no problem. Go ahead, sir. There was some audio issue.
Okay. Okay, no, no problem. Because it is about to finish. Now, I thought that because somebody do not.
No,
If it is,
we'll take up the, if some audience has any questions, we can take up at the end.
okay, sir. Because I am also going, because if it is so, I am already about to end my lecture. Okay, sir. So
No,
now different switching states are there. You can easily see that number of switches are five here, 1, 2, 3, 4, 5, and all are not conducting. So again, and it is not shown here that these are hard, this is hard switching or soft switching. So again, if somebody is listening carefully, he can write in his copy that here we can do the work by applying the soft switching. So that will be another area. Now this is about the switchings of the different switches S1, S2, S3, S4. Here deliberately S2 is not written. You can see here S2 switch, if it is there conducting, we can provide power from output to input side. So this converter can be used for means it is also called bidirectional converter. If I utilize this S2 switch, so that's why I am removing this portion. Key S2 is not there, and only for explanation purpose, S2 is drawn here. Means if the my area is power electric converter, but it can be applied for electric vehicle or in power system also. So you can think that in the load side, if power is generated by any means for regenerative, suppose regenerative braking is there, so that power will be given to means it can charge the battery. You can also think like that, and at that time you can see a D5 switch is connected, so it cannot go to the V1 source, and a switch is there S4. It will not go to that particular V2, which we can assume the fuel cell and the solar panel. So only that output power can charge the battery also. So these five modes are not showing that operation where the output power is more as compared to the input one. So somebody who is working, he can also think कि bidirectional power converters, multi-port power converter are also there. So he or she, not only she and he both can work on that direction also. So that is also possible. And you can also see it is a non-isolated converter. Again, it's a problem. So for only for initial idea, I am saying we can start the work like that, where the common ground, again another issue here, the ground is common, the input and output grounds are common. Again we can think about common ground and non common ground like that. So again another issue is there. So now you can see for discharging mode operation means from the input side the power is transferred to the output only. In that case, uh, the switching strategy like this, for the up to 0 to D3 time, D3 T time, we have this S1 is on, S3 is on, S4 is on, and S5 is on. For D3 to D4 T time, we can see S1 is on, S3 is not on, S4 and S5 are on, and accordingly the inductor voltage is coming. So these are the simulations. So you already know practically if we did it, different results are coming. I will show you that also. Earlier, when we only did simulations, we saw everywhere only current is given. So we just check that how voltage is coming, not only for voltage, volt second balance and current second balance and finding the steady state relationship. We did we checked the VL and we find that it is coming like this, means it is coming in steps. So and then output side you can see, because we have a 240 watt converter, because what was the limitation we I want to tell you. In my lab or in my room where I did that research, um, we have a 3 ampere power supply. So if we have the voltage 240 volt, so we can go up to 1 ampere for output. And if it is 120 volt, we can go up to 2 ampere. So that's why we you can easily see, when if current is not shown here, so the current will be taken as this one, up to 2 ampere. But because inductor current is very large, so then we have to we utilize the power supply which has more than 2 ampere, and then we perform the experiment, that okay, yes, it is possible, because that inductor current is coming from the input side. So we have to see that aspect when you perform the experiment also. So we design a 240 watt power supply converter, but in the input side, because it's if it is efficiency is 90%, you can easily see the input uh, input power supply may have the more current rating for that, if we use all at the same time. Or we can also think like that, if three different power supplies are there, apart from one battery we have two power supply, then it will also work. So I want to tell you this thing, when you perform the experimental work, we have to think in that manner also, ki how to design it as per your lab, or as per your the facilities available in your lab. So here we design it like that. And you can see some hardware is not shown here. Yeah, this was the hardware developed by Dr. Ashutosh. Now because he completed his PhD, so he is not my student now. He is Dr. Ashutosh. So he did very good work and did develop this one. So you can see if we find the results by in this setup, so too much interference is there. The wire length is also another issue. So whenever we get the inductor voltage which is coming as this one will not come like this. I will show you that one also, but I want to show you that if you work in your lab, the setup will be shown like this. uh, Again, the inductors design maybe must be not ideal or optimum. So that type of issues, if you are working, you are perfect and you are not purchasing from somewhere, then you can develop it step by step like this. So now I am interested in this part. I want to show you this thing, that the inductor voltage, which is ideally is coming straight lines in steps, is not coming like this. Although ideally, sorry, practically it is near to that particular this one, the simulated one. And similarly, you can see whenever switching is there and whenever some other components comes into picture, we will not get the exact inductor current like we got it. And of course, in the output side, we are connecting a large value of capacitor, say 1000 microfarad. So we will get very less means fluctuation in the output voltage, and we will get the result like this. That 60 volt and the total voltage is 120 volt. Now, similarly for this one, we are getting the uh, different loading conditions are there for 120 watt and 240 watt, 360 watt, up to 360 watt. So we will see the voltage is coming almost constant. So why I showed this result to you? I want to show you that the controller which we designed is working properly. And for those who are initially working on it, they can start from first developing the dynamic model, doing the making the Bode plot, developing a simple controller, PI controller, and do that work. And then check whether by changing the load or by changing the input, whether you are getting such type of output in simulation or not. And then they can think about the hardware. So this is about that also. And this is about the efficiency. So at different duty cycles, different not duty cycle, different combination of the duty cycle, you know that d2 is not working because we did not work on the bidirectional converter. So only d1 d2 sorry, d1 d3 d4 and d5 switches are there. So these are the percentage of the duty cycles. So by providing the different duty cycles, we found the efficiency. Now it's a headache for everybody that how you take 40 somewhere 30. So infinite number of possibilities are there in this also. And uh, I showed you only the optimum results where the efficiency is a little bit okay. So I say little bit okay means 70% to 90%, or around 91%. So for different again, it's another work, optimizations, optimize switching to get the high efficiency of the given converter which I showed to you, so that you can work and you can publish a paper on it also, which I did not work. So you can see at 240 watt, because we design it for 240 watt. So I say that for that particular power rating, what is the maximum efficiency? I have to say like that. So at 240 watt, you can see the red graph shows the maximum efficiency with the duty cycle of D1 and D5 as 60% and D3 and D4 are 40 and 50%. And we draw it a separate curve like this for this red one, because instead of confusing audiences or the other colleagues, I draw, not I, my student draw this diagram that for this particular 240 watt, the efficiency is approximately high. So we perform it practically. It's not a theoretical result. These are the practical results. Theoretically, we got more than 95% efficiency. And if we use the single converter, single input, single output, we will get up to 98% efficiency. So whenever we do some work, we have to think like that. For multi-port converters, that efficiency is not very high, and we can work on it. So this is about the multi-port converter, which I discussed here, and different aspects may be possible of these multi-port converter, and different applications are also possible, which I at the starting I started by this one, uh, this diagram. Sorry, this one, this. So you can work like that also. Just I saw some papers, the people are working like that. Uh, the two converters they used and providing a constant DC bus voltage, and then it is connected to one load. So now the people like me say, okay, I will do something different. I will show it different. So I just place, instead of these loads, I just say I want to charge a battery. Now sources are different, the solar, hydro, and like that. Instead of all one, I can say solar and battery. So if you use wind, you can say no, no, I want to, because the wind, by the wind I got that AC supply. So you can convert some AC to DC converter and connect it to a DC grid. So this is one type of work for where multi-port CISO converters and different renewable energy sources are integrated. And this is the another work that you can work on different energy sources with if I say inverter means I definitely want AC load in the output side. If I say, okay, want to remove the inverter, I can say I will provide a DC supply at the output. So the same lecture can be modified by our audience or a colleague. I think they are also already working, so they can just change it and include it this one. But I place the name of my the contributors also, my means Dr. Ashutosh Gupta and one faculty member who was earlier my MTech student, Mr. Shreyans. He is doing PhD from IIT. So they contribute here. That's why that I have to write their name also. So you can easily see that by that one we can apply those multi-port converter in power system. The another work is the nowadays working on the IoT based systems. So we can work on the um, different manner also, that these converter can not this one, these converter can means communicate with each other. So we can, that type of work is also possible. We can go for the protocols also, communication protocols for this one. If the this load will be EV, we can think like that the one converter can talk with the other converter also. So different type of work and different ideas may be there, and my aim is only to tell you ki only this is a very simple work and already available in the literature. I am only doing a small work and want to show you ki these are the steps by which you can do the work. So I am working on that side, and not all the part I am doing, only I am working on that part, multi-port converter. So and doing the renewable energy sources integration with that, and then whether I am getting proper supply or not. Then we can, I am also working in that direction now. If I want to charge the battery available in this electric vehicle, so again, one more converter is required. So when it is stationary, it is connected to single phase grid. And when it is not stationary, means it is moving, then that renewable energy sources will provide the energy to this particular battery, or utilize for this electric motor. So again, that power balance and the other thing can be possible in that particular work. So this is about my presentation, and I think I am done. So thank you very much. And this last slide I want to show you first now. Sorry, uh, this one. it is the most important part. I want to give thanks to the students if they are, although I am thinking that I am also a student. So let we are colleagues, audience, organizers, and also the various references, because everything is not draw means written by me. Some references are also there, so many, not some, so many references are there, and those diagrams are taken from not all, some diagrams are taken from the references. So I have to write those references also, which I forget to this particular presentation. So thank you very much, by for this lecture, and patience also. And now if any queries there, you can, and or if you want any discussion, I am available here. So thank you, Agrawal sir.
Thank you, sir. Thank you. Sir, can you tell us one or two basic references and useful references for the audience?
Sir, there are so many references. You can
One or two
mail
basic
me.
reference which you have found very useful, because
Okay, okay, okay.
many references, people, some references are
Confused.
complicated. People
Con-
do not understand sometimes.
confused. So, okay, let I write. I will tell you one reference is one book written by Erickson. So, by that particular book, you will get so many ideas. So, when I say references, first I started from the books, because whenever research papers are there, there are chances some means some problems are there in those research papers also. So Erickson book is there, by that I got all those ideas. So this is the first reference, and the second reference is by the Maximovic book. So Kazi Murzik book. So by that people can work on the basic idea, because the basic theory is also required, sir. So the people can work on those. This one, there is one also the one paper that is written by P.L. Chapman, where multiple input DC to DC converter topology is there. So sir, uh, if somebody is interested, I will provide him also. But because you are asking, so is it okay, or I have to tell more?
You can, Mr. Whenever you send your presentation to us, because this presentation is needed to be uploaded on the ATAL website. Along with that,
Okay.
you can send a Word file by mentioning those good references, and then we can share them with our participants.
Sir, actually, I will when I will add the references in the PPT itself.
PPT itself. PPT
Itself, it is better, because whenever we do something, we have to give full credit. It is only written here various references used. So I will give credit to those persons, and I will write the name of those persons with one PPT along with it, and will send it to you as a PDF or in that manner also.
Sure,
So
sir.
it will be useful for others also. And one thing is, my mail ID is there, sir, at the starting. If anybody has query, or want to discuss, not query, okay, I will write my number also, 958285175. So he can uh, uh, call me, or he can WhatsApp me also, mail me or WhatsApp me, so that we can discuss more about this, or collaborate more about this research work.
Sure, sir.
And
So,
whatever other thing are required. So shall I have to ask the questions if somebody is not asking to me?
no,
Generally in the course,
no,
the
sir. You
audience
need
is
not.
asking.
No,
Huh?
no, you need not ask the question, and
Okay.
just you can add whatever. If you want to add some questions, basic questions in your slide, then it's all right. Otherwise, it's not compulsory.
Nah, yeah, I will add the references as well as I will add some basic questions there
Sure, sir. Sure.
for
So,
exercise purpose.
yeah. So, are there any questions from other participants? And if there are no questions, then I think we can wind up.
Good morning.
Sir, in this converter, can we add AI tools or machine learning tools?
Yeah, correct. Actually, in my previous presentation, not this one, I already utilized the artificial neural networks
Yes.
practically also in the lab by using a microcontroller, which is a cross of DSP and microcontroller, that is TI, TI based microcontroller, 28379D. So just by including the um, program part, we can change our simple PI controller to that particular ANN controller also, and we get very good results. But you know that when we use the AI, so a proper training is required. So from where you get the training, you have to at least perform the experiment in the lab in hardware.
Yes.
So it is possible. So in power electronics, basically, you can publish the paper easily just by saying that I am using ANN and the any other technique as a controller. But when you perform the experiment, you can see everywhere generally in this part. The researchers are working on the actual controllers instead of AI based controllers.
Yes.
Only for research purpose, we can work on it also.
Yes.
Okay.
Sir, and
So
any book is available for neural networks, sir?
actually,
And
my
if you
topic is
have any idea?
actually my topic is not that. My topic
Yes,
is
sir.
not about Canada. But if you want to ask, that we have a Simon Hacking book where the
Yes.
not power electronics converter, where the neural network is there, and there are so many thousand books are available, and you
Yes.
can find the knowledge of the neural network from that. Okay. And so many not books, you can go for the lectures of the great researchers of India, of our India, from IITs, from ISC, right? So their lectures are available. You can go through the website and you can find the information from that also. One great professor is now, I think, I don't know now or not, is director in this MNIT Jaipur, Professor Padi. He also did very good work in that direction. He has a book also. So
Yes.
whenever we have to ask, we have to explain these things. So we have to say our Indians are also best. So one very good book is written by him, Dr. Padi. So you can search on the net. Soft copy is also available. So you can study the neural network from that instead of Simon Hacking. Okay.
Yes. Thank you, sir.
So Sanjeev sir.
Any other question? Any other participant who may want to ask any question, he may write in the chat box as well.
Okay, in the chat box, I am chat box only. Good morning is written.
So if there is no question, I think we can wind up.
It
Thank
means
you, sir.
okay, sir. Okay, thank you, sir. Thank you.
Thank you, sir. Thank you. We'll join the next session at 11:50. 11:50 will start the next session.